Today's question is asking us to remove the nth node from the end of the list. So let's go through the example here. We have this linked list that goes from 1 until 5, and we get as an input the list, or the head of the list, this node, and then we get an index which is n. And n represents the node to be removed, the index of the node to be removed from the end of the list. So in that case, we go from here 1 and then 2. So node 4 should be removed. So the goal is basically to remove that node from the end of the list and just return the new head, or the head with the removed node. So take a time to think about a solution here. You can right away, this would have been an easier problem if we had the index of the element to remove, but since this is a linked list, we really don't know the length of the list. So how about we do that? We can try to convert this question to a simpler question, which will be, instead of giving this n, we can try to find the length of the current linked list and then subtract from it this n. This will lead us to get the index of the node to be removed without having any other issues. So if we just think about it, it will be in 3 steps. One is to, let me comment this out. One is to iterate through the list to get the length. This is the first step. Second step is to get the index of the node to be removed. And the third step would be to iterate again and just basically remove this node. So if you remember a linked list, how we remove nodes is as follows. Is that we basically do this trick. So we go from, if we start here, I hope this is obvious. No, wait a second. So if we start at this node here, we link here, that's fine. We link here, it's okay. And then we want to remove this 4. So what we do basically is break this link here and pointing to the one after. That is how you remove a node from a linked list. So again, the steps that we were gonna take is basically find the length of the linked list. 2 would be to get the index to be removed, and this will be equal to the size or the length that we found at step 1. This will be equal to length minus n, and the third step is iterate and remove the node as we have seen here. This is the process. So let's get to coding. I hope this is a bit clear here. So in the beginning, I just make a copy of the head because I don't want to lose the head. I make a copy of it, and we go and make, while the head is still there, we just keep iterating to find the size and increment the value of size. So here, by the end of this loop, you would have a variable called size, which is the length of the full linked list. That's the step 1. Step 2 is to get the index, which will basically be the size minus n. So that's pretty straightforward here. And now comes a bit of a tricky part. So with linked list, usually you should be careful when you change the head or change the node, because that means you can lose reference to the beginning of it. That's why we always make copies. And there's always a technique that's currently used or commonly used in linked list question, is basically to make a new node that starts at position 0, like it doesn't need starting before, so it has value 0, and then you link this new node that you create. You make the next to head. So if we can look again in the iPad, we basically insert a node here. This is the dummy node, or I called it here new node, this one here, and we just link to this one, as we can see here. So that's the node that we inserted. And what we need to do here basically is just have a pointer to the new node, and we basically have a counter here to count which index or which step we are in, and simply we iterate as long as we're less than this index. So by the end of this loop, what we will have the node pointing pointing to the one before it, so it will be pointing to 3 in that case. So the node will stop here. This will be the one that we just, the current. This will be the current. And what I want to do, I want to do the third step now of basically instead of making current.next to go to 4 as it is, I want to skip that 4 because that's the node what we want to remove. So I say current.next is equal to current.next.next as I see here. So this is the current node that we want to remove. And at this step, basically, I want to cut this tie and just go from, instead of here, I want to go to here, to node 5. And this you do simply by adding this current.next is equal to current.next.next. And in the end, we return the new node.next, and that's it. So the why.next, because as if you remember, we started at a new node that was not pointing to anything, and then .next is the head. Of course, you can do that differently here, so you don't need to create a new node. You can just make a copy and return it. That would be fine, but I just like to standardize because this is usually how we solve the linked list problems. So that's the first solution. Let's try to analyze the time and space complexity. So if we go through it here, we would notice that for every variable or like length of linked list, we have to go through it at least here once, yeah? And then another time here. So we loop over it 2 times at least, which would mean that the time complexity here would be O of n, where n is the size of the linked list. And if we speak about space complexity, so the space complexity here is constant, yeah, like the space will not change with the input size, so it's O of 1. So that would work, and if you check the submissions, this gives you also a good runtime. However, there's also a challenge here, like another one. Can you do that in 1 pass instead of having 2 pass? And this we're gonna cover in the next solution now. So I have 2 solutions. This is the intuitive one where we just get the size of the linked list, then subtract the n, then we know from the beginning the index to be removed. We just loop over it until we find that node to be removed and we unlink it. That's the solution that we just made. However, I'm gonna show you another way how you can solve it in even 1 pass.